Ladies and gentlemen, I thought long and hard about what to talk to you about today. I thought I could talk to you about email, but you already know about that. I thought I could talk to you about virtualization technologies, but you probably already know about that. So what I'm going to talk to you about today is change, and therefore IPv6. There's a change coming on the internet that some of you may be prepared for, and I think many of you are not. The number of IPv4 addresses on the internet has been dropping sharply, and I think a lot of you in this room might be ready, but we're here today to deal with the change that's coming on the internet. So, why did I wear cufflinks when I was going to do this? IPv6 is here, ladies and gentlemen, and we're going to have a little bit of a chat about that today. The aims of this workshop are to give you a bit of an introduction. It's difficult to do anything too practical in this setting. To give you an idea of what IPv6 is, why we need it, and when it's happening, and start to go through some of the things you can do to prepare and get started in using it. If you've been watching a lot of the popular press lately, you will see many doom and gloom stories. Some saying that the internet is going to come to an end, that basically lots of infrastructure is going to stop. Well, it's maybe not that bad, but we better get ready. I say that IPv4 is running out. It has actually officially run out. It ran out last year. IANA, the guys who look after things like numbers, port numbers and so on, have none left. Basically the way it works, IANA hand out IP addresses to each of the regional registries, and when they run out, they go back to IANA and ask for more IPs. They're not going to get any. There isn't any more left. That, according to Hurricane Electric, is the number of IP addresses left as of last week, each of the regional registries. So we better get ready with IPv6. But first, how did we get here? An address is just a number. There's an infinite number of numbers. How can we possibly be running out of addresses? When you build a new house, you don't have to worry about addressing schemes and this sort of thing. Why do we not just have an infinite number of addresses on the internet? Especially given such clever people designed the internet. The systems such as DNS and so on have been in use for many years, are very scalable, and unfortunately the addressing system that was chosen isn't. Why is that? Well, a lot of it comes down to scalability again. You'd think that having an infinite number of numbers would be a fantastic way to go, but if we just started with the first computer that was built and put on the internet and called it number 1, and got another one on the other side of the world and called it number 2, and so on, you'd soon run out of memory on routers and so on. You need a scalable system for looking up addresses and knowing where to send packets. So if a packet arrives at a router, it needs to look up in a table where to send that onto, and these are not always very big or very clever devices, and so routing tables could be very, very large on an infinite-sized internet. So initially, we had Class A networks, Class B and Class C, so the smallest network there is the Class C, and originally if you wanted an IP address you would need to get an entire class C, which is 254 usable addresses. You can imagine with the growth of the internet how long we'd last if we were handing things out at that rate. So a few mechanisms were brought in to deal with that and try and extend the usage of internet addresses. One of the mechanisms was CIDR, classless internet inter-domain routing, and basically that enables you to create subnets to take a class C, which is 24 bits of network address, and the remaining 8 of hosts, and split that into two /25s, each half the size. This still allows us to aggregate our addressing, but doesn't solve the underlying problem. In a further desperate attempt to try and limit IPv4 usage, NAT was brought in. NAT is evil. Those of you who are network and systems administrators will know this. NAT breaks one of the fundamental principles of the internet, which is that every device can talk to every other device. Everything must on the internet have a public IP address, and in NAT you don't get that. You have one public IP address on a router, and you have a number of client machines behind it, and when they want to talk to a server 1, for example, they use the public IP address of the router. However, if server 1 wants to talk to the client, most of the time it can't. Some people see this as a security feature, but really it isn't. Basically, it means that if you want to run a web server on the client, you can't. If you want to be an active part of the internet, you need an IP address. NAT breaks all sorts of things. Hands up those of you who have done any voice over IP work, perhaps with asterisk. Is NAT your favorite thing? Yes. So you end up dealing with stun servers and all sorts of things to get around the brokenness that NAT introduces. NAT is about to die as IPv6 takes over. So, IPv6, a new addressing system for the internet. As I said before, we've run out. So what happens now? Well, first of all, there are no more provider-independent assignments that are going to be handed out. If you are if you want a block of IP addresses that are not attached to a particular hosting provider, ISP, then you could previously go direct to one of the regional registries, RIPE in Europe, and ask for a provider-independent set of addresses. They will no longer do that. Secondly, the ISPs that you're using are going to start recovering unused IP addresses. Many of them are already doing audits, checking if you're actually using the allocations you've got and claiming them back. Thirdly, they've stopped, many of them, handing out IPv4 addresses. They're becoming far more restrictive with what addresses you can get. And some, if they didn't already, have started charging for IPv4. Finally, when all the regional registries have run out and all the ISPs have run out, you're going to start getting IPv6 only connections, which means when you want to get a broadband connection at home, you want to get a web server set up, it's going to be IPv6 only. That's going to be an interesting time if you're not ready for it. So we need to start learning about it now. Any Douglas Adams fans in the room? No? Yes? One. Thanks, Dan. Yeah, IPv6 is big. Bigger even than the Spanish, or to the UK, to be honest, budget deficit. We have 128 bits of addressing space to play with, which is a big number. That, with 7 billion people on the planet, is 5 times 10 to the 28 each. So, it's big. What else? There have been a few other changes. The architects who were designing IPv6 decided to fix a few other things about the internet while they were at it. Packet headers are fixed in IPv4. In IPv6, they're extensible, so they're much smaller, but you can dynamically add more of them. We've got, instead of, or as well as DHCP for automatically configuring a network, we have stateless auto-configuration. So if you have a router advertisement daemon that is running IPv6 on your network, your IPv6 device will simply take the advertisements that arrive that tell it what prefix is going on that network and configure itself automatically with an IP address. You don't need to do anything. If you bring your laptop and plug it into our network, you will just get an IPv6 address on most machines, any modern Windows, any modern Linux operating system. Whether you want one or not, you have to deliberately turn that off. So we'll come to this a bit more in a minute, but many of you are possibly running IPv6 already, or have IPv6 things happening on your network that you don't know about. That can have some security implications. We'll come to that in a minute. IPsec, it was sort of backported and put into IPv4. It comes for free in IPv6 if you choose to use it. So you've got an encryption layer built into the IP stack. Many of you network administrators out there will be familiar with many of the problems that occur with packet fragmentation. When packet data is passing through a network, it gets to a point, a router that has a different MTU, or maximum transmission unit size, and it needs to send an ICMP message back to the source saying please fragment, which means there's a delay. It drops the packet it's just received and waits for some more to turn up. This can cause all sorts of problems, and if you've got VPNs within VPNs, then your maximum transmission unit size, MTU, can be quite small. We don't have that in IPv6. There is no such thing as a please fragment. What happens is there's an end-to-end path discovery that happens. So when the source and a destination want to talk to each other, they figure out what is the maximum transmission unit size for the entire path. They do a path MTU discovery and then work on that basis. If that changes for any reason, then instead of a please fragment message, you send back a please do a path discovery message, essentially. And we won't go into any detail on this, but jumbograms, very big packets. If you have a huge MTU available to you, a huge path, say you're just on a local network, you control all the switches, and you want to do media streaming on a LAN, then jumbograms are for you. You can put enormous amounts of data through. I think 2 to the 64 bytes or something like this. Quite a lot anyway. We have a new address notation. I was meaning to ask if there were any 4-letter Spanish words that could be spelt in hexadecimal. Cafe. Well, there we go. We've got cafe. I'm not sure about dead and beef, but this is one of the common examples you get. It's great fun to spell things out in your IP addresses. If you look up the IP address of many web servers and email servers out there, you'll see strange things in there. Often people put their port number in because you've got so many IP addresses to play with. For a DNS server, you can run it on network 53. In IPv4, localhost looks like that. Not too hard. 127.0.0.1. In IPv6, it's a bit different. That's a lot to type. You're going to get very sore wrists every time you want to connect to localhost on that. Fortunately, the designers of IPv6 thought of this. They realized that there's going to be, in 128 bits of address space, some zeros we probably don't want. So first of all, we convert it to hexadecimal, which makes it a lot shorter. We've got 8 octets. And then we can get rid of all the leading zeros, because we don't really need those. And then we can get rid of the, I don't know how the translator is going to deal with this, but the longest contiguous set of zeros, the longest adjacent set, consecutive, thank you, set of zeros can be compressed using 2 colons. So actually, localhost looks like that, which is even shorter than in IPv4. You can only use the double colon device once in an address, for obvious reasons that might become obvious if you think about it. You can only get rid of one, or the longest set of zeros. So you end up with addresses that look like this. That's the documentation prefix if you're writing example documentation for your software for when you implement IPv6 in Zentyal. Then that's the prefix you should use rather than some random address that you've made up like Dead Beef Cafe. The allocation sizes you get, I say you've got 128 bits of space to play with. When you go to a regional registrar such as RIPE as an ISP, you will get a /32 as a minimum, which is a lot of addresses. As a customer, if you go to an ISP, you will generally, or you generally should get a /48. You won't always, but you should. One subnet is a /64, and only one host is obviously in 128 bits, a /128. So, on to deployment. You have 2 options, really, when it comes to deployment. You have the option of going native, or you can tunnel. So if you choose to go native, then you need to get a Mel Gibson and paint him blue. Or perhaps not. You really need the full support of your ISP. If you want full native connectivity, your ISP must have IPv6 transit upstream. They must support IPv6 within their network, and they must get that IPv6 connection to you natively. So that's going to require that their hardware supports it, possibly depending on the technology that your telco's hardware supports it, and many don't, and that whatever router you're using also supports it. And until recently, for a home network, this was basically impossible. Certainly a couple of years ago, there was not, that I was aware of, and I challenged people a couple of years ago to name one, any commodity hardware, any small office, home office hardware, anything under about 500 quid, that, or $500, euros even, that you could use that supported IPv6 natively. So you basically had to use a tunnel. There are a number of transition mechanisms that are in place. There's obviously, we can't just change the whole internet at once. We're going to be rolling in IPv6 progressively. It's already started. It's been going on for over 10 years. You might not believe it, but people are starting to get a little more serious about it now. And there are quite a few transitional mechanisms to make it easier, to make IPv6 work even where it doesn't want to make IPv6 work even with routers that don't have any knowledge of or support for it. 6 to 4 tunnels are quite common. There's all sorts. There's more than I've got listed up there. 6 in 4, when you've got 2 IPv4 endpoints and you want to connect them together. I'll show you an example of that in a moment. 6 over 4, I don't even know what that is. I've never used it. Teredo tunnels, Microsoft development, which can be used. You can use it on Linux, although it's not enabled by default. It is on Windows. Basically, it deals with NAT. So if you've got 1 or allegedly more layers of NAT, then Teredo tunnels will get you onto the IPv6 internet even with no other support. It works in all sorts of strange locations. Very, very clever, and oddly coming from Microsoft. So 6 in 4 tunnels. If you want to connect 2 IPv4 endpoints that you control, or rather your IPv4 endpoint, perhaps on your Linux router or firewall, with a tunnel provider, perhaps Hurricane Electric, sorry, or 6.NET, or whoever your ISP is, if they can offer you a 6-in-4 tunnel, then you can configure it with a bit of bash programming like this. Specify the device and what your local IP address is, the local remote, the remote IPv4 address, what your local IPv6 address is, and note the 1/64 on the end. The 1 could be just about anything, but the /64 is your subnet, and the time to live the tunnel. We create the tunnel with one line. IP is our favorite command here. So that creates the device. We bring that device up, add our local IPv6 address to it, and finally add a default route. Looks a little bit different to what you would normally use, but ::/0 is basically everything IPv6 go here. Teredo tunnels I mentioned. Okay, who administers an IPv4 network at the moment? How many Microsoft providers have we got here, or have we got anyone who administers any Windows networks here? No. Okay. Oh, we've got one or two. Are you aware of the IPv6 setup in Windows? Okay. You're aware it's on by default? Okay, this is good. I've come across many people who are not. Since Windows Vista, Teredo tunnels have been enabled by default, which basically means if you're upgrading from Windows XP to Vista or beyond, then you've got IPv6 on your network, even if you didn't expect it or realize it. A lot of people have been caught out by that. The various content filtering programs, privacy programs, this sort of thing, can be easily circumvented by somebody sitting on a Windows PC, even though they're not trying to get around your security. Microsoft's done it for them as a sort of means to try and get IPv6 out there, because people aren't bringing it in. As I say, it's been around for over 10 years and it's not out there yet. So how it works, basically, as I understand it, I'm not much of a Windows person, I have to admit, but essentially, if, say, a website is configured with both IPv4 and IPv6 support, then it will just go to the IPv4 address. If it is an IPv6 only connection that you're trying to make from your machine, then it will tunnel out and find its way there, much to many network administrators' surprise. So I mentioned earlier the router advertisement daemon, an alternative to DHCP, essentially. If you want your network to configure itself with minimal input from you, then you can install RADVD on Linux, apt-get install on a Debian-based system, configure it with a prefix, basically just an IPv6 prefix, whatever your provider has given you. If you've been given a /64, then pop it in there. Your devices on the network that know about IPv6 will then simply auto-configure themselves. They'll give themselves an address based on their MAC address. And you can tell one when you see it on the internet because it looks like that. You basically get the subnet, the prefix that I was talking about, take the MAC address, stick a 2 at the beginning of it, note the underline, stick an FFFE in the middle of it, and even out all the colons in the middle, and that's your auto-configuration address. You can reverse engineer that, of course, if you see one of these addresses on the internet. Look at the prefix for their MAC address and figure out what type of hardware they've got on their network card. So you can often tell that somebody's using a Dell laptop, and they can be quite surprised when you tell them this. There are ways, privacy configurations and so on, that you can use to prevent that sort of thing going on, but yeah, by default, your MAC address is visible on the entire internet. So DNS, we have A records, obviously, for IPv4, rather than simply sticking A records with IPv6 in there. That would break a lot of DNS servers and various other software. It was decided there should be another record, a completely separate record. Initially, there were A6 records. Forget about them if you have heard of them. They don't exist anymore. You shouldn't be using them. Quad A records is what we use, AA. So when you're setting up DNS for example.com here, obviously you shouldn't be putting a private address in as your A record, but you may want to. You can configure both an IPv4 and an IPv6 address for the one host. And it looks like that in a typical bind configuration. Reverse DNS is a bit of a mess, to be honest. If you want to configure reverse DNS for an IP, then it's an awful lot of typing. You've got all the bits to string out there. You can tidy it up a bit using origins. I tend to use an origin of whatever the network prefix is, but you still end up with an awful lot of cut, paste, and fiddle, and typing 128-bit numbers backwards. There's various tools to try and get around this, but yeah, that's the basics. And if you're familiar with bind 9, generate, and so on, don't. If you're thinking you might use generate automatically the IPv6 addresses, 128 bits, as I pointed out before, represents an awful lot of numbers. If your bind setup tries to do that in memory, then you might not have a bind daemon running anymore. I believe in recent versions of bind they're doing something about this, but I haven't looked in the last couple of versions, so there may already be something that can do that. But mostly people use scripts and tools, or just don't set reverse DNS for IPs that aren't in use. We'll get better tools as people start using IPv6. It's the case generally with IPv6 that support is very mixed in software. I'll come to more of that in a minute. Finally, if you want to do a full IPv6 deployment, you need to have the support of your registrar. So not just your DNS, but go up a level, the registrar where you register your domain records. You need to tell them where your name servers are. And glue records, you'll be familiar with possibly from IPv4, enable you to set name servers with the same domain name as the thing you're trying to serve DNS for. So if you want to set example.com to ns1.example.com, then you need some glue records to do that. Unfortunately, an awful lot of registrars out there don't support IPv6 addresses in their interface. Some software, or an awful lot of software, supports it in the background, but a lot of registrars haven't updated their systems to allow you to put an address in there. A good registrar will let you set both an IPv4 and an IPv6 glue record for the same name server. Nominet, which looks after .uk addresses, will do so. Most others won't. You can choose one or the other. So if you're setting up, say, 3 name servers, you might have 1 IPv6 glue record and 2 IPv4 glue records. Yes. If you want to type an IP address into, say, your Firefox address bar, obviously you can't just put the colons in as you normally would, because that signifies that you're about to put a port number in. This is a common IP address assumption that's been made in a lot of software. XIM, anyone here use XIM on their servers? Hands? No? Nobody uses XIM? Oh, 1 or 2. Basically, colons are used as address separators. When you want to put a list of IP addresses or a list of hosts, they're separated by colons in the XIM config file. And so there's all sorts of tricks to get around it. And XIM being XIM, it's not particularly consistent. In some cases, you stick some square brackets around it. In some cases, you double the colons. You can imagine that starts to look very pretty. So I just put that up as an example that a lot of different bits of software have done all sorts of workarounds to make IPv6 addresses work when they've used colons for other things. We have a number of tools we can use for working with IPv6. Many bits of software have basically put a switch in to say that you specifically want to work with either IPv4 or IPv6. And in some cases, we have a completely separate tool. So instead of using ping, we'll use ping6. Instead of using traceroute, we've got traceroute 6. SSH and IP and ifconfig are all dual stack. They all work with both. But you can specify a switch to say which address you want to use. So if you're having problems, for example, you're testing with IPv6, you set up a quad A record for your server and you can't SSH to it anymore because you forgot to open your firewall, for example. Not that that would ever happen. Then you can specify -4 to make sure you default to an IPv4 address. Otherwise, by default, most things will use IPv6 first because it's the way forward, it's faster. You will notice a slight speed increase using IPv6 in many cases. But you can force it with most software. TCP dump, you can tell it IP6 to use IPv6. For those of you who like to handcraft your firewalls with IP tables, IP6 tables is your new friend. It's almost identical in every way. And also for those of you who like to handcraft your firewalls or just generally know what's going on, you might want to have a look at what protocols are in use. By protocol, I mean in IPv4, in IP tables, if you're specifying a -p for all or TCP or UDP, there are more protocols than that. There's obviously ICMP, various things with that. The main one you'll care about is protocol 41. So basically, if you need to do a 6-in-4 tunnel, then you should have protocol 41 open. If you want to work with various other things, you're going to need other protocols. So you may need all of those to be open, so you can control exactly what's going on with those protocol numbers. So, where are we? IPv6 deployment. We've had over 10 years to get it out there, and it's not really there yet. Of the number of top-level domains that have, all of the top-level domains, and by that I mean .com, .net, .es, .uk, only 89%. Again, this is from Hurricane Electric's site. I've used them for all the statistics, as they publish quite good statistics on their website. There's only 89% that have that. In terms of glue records, which I talked about a moment ago, 86.8%. And again, this is the very top level, so .com, not just example.com. ASs, anonymous network. Sorry, autonomous, not anonymous. Autonomous networks. So if you are a hosting provider, you are running your own network, you will get an AS number from RIPE, for example. The number of them that are publishing any IPv6 routes is only 16.2%. So it hasn't got very far. And of the top domains, that's the top million domains that are showing up on Alexa, only a bit over 40,000 are directly reachable with IPv6 addresses. It's pathetic. So if you end up with an IPv6 only address at this point in time, you're going to be a pretty poor internet citizen. So fortunately, many of the big websites have got it. You can get to Google via IPv6 as of about a year ago. They've had support for IPv6 longer than that, but only, and I mean only, if you went to ipv6.google.com. If you went to www.google.com, then you were only presented with A records. They said, I believe at the time, that they wanted their users to have the best possible experience, and sadly, because a lot of people don't know about IPv6 and aren't properly implementing it, there are a lot of broken setups of IPv6 out there, which means if you by default try and go to an IPv6 address because your machine thinks it's got an IPv6 address, then you won't get to that website or to that mail server, and that can be a bit of a problem. So Google for a long time decided they were only going to provide IPv6 if you went specifically to that address. I believe on IPv6 Day last year they changed that. It might have been the year before. And a number of other big websites went IPv6 as well to try and get this out there. There was a sort of awareness day for IPv6. So why, given that this is coming and that without it we're not going to have a functional internet, haven't we got it? Well, fortunately, all of you are here, presumably because, well, the pub's not open yet. No, sorry, you're here because you wanted to learn about IPv6, and that's a good thing. So inertia is one of the reasons. A lot of people can't be bothered with change, really. If it's not a priority today, if nobody's nagging you about IPv6, if you can get to all the websites you care about using IPv4, then why bother doing anything about it? I'm sure it'll just fix itself. A lot of people don't have any real knowledge of it. Knowledge takes time or money or both to acquire, and not every conference is running an IPv6 session to teach you about it. Not everyone's got the time to put into learning about it. As I mentioned earlier, small office, home office hardware, those cheap devices that you use, the little Netgears and D-Links and so on, up until very recently, none of them had any IPv6 support at any affordable price. So you basically had to set up a tunnel to get any kind of IPv6 support. That's no longer the case. Our ISP gave us a lovely shiny little Technicolor when we needed a new router recently, and that had IPv6 support for both cable and wireless. So you automatically are getting a router advertisement daemon, putting out announcements on both Wi-Fi and on the wire. But there's still a lot of kit out there that doesn't support it. Some of the open source projects, OpenWRT and so on, didn't support it. I think it does now. An awful lot of software had non-existent or poor support for IPv6. I haven't done any Python twisted programming for a couple of years. And the reason I stopped, the main reason I stopped, was because I was trying to write network software, oddly enough, in a network framework, and it didn't have IPv6 support in it at the time. There were been bugs open for years and various discussions around it, but it wasn't easy to put in. Twisted had been around for quite a while and was quite set in its IPv4 ways. It's not the only one. We've found bugs in XIM, and if any of you have used Quagga for doing BGP and OSPF announcements, in the BGP part of that, the version that was in Hardy Heron anyway, Ubuntu 8.04 LTS, which we used quite a lot, did not, or had quite a serious bug in the IPv6 implementation. So we ended up having to backport something from Debian. And finally, many registrar systems don't have proper IPv6 support. So, and many other websites and so on where you need to type an IP address in will tell you you can't put a colon there, go away, or that address is too long. So it's a problem, and we need to fix it. So what can you do? The internet's going to stop working properly for a lot of people if you don't do something. So you're going to learn about it. I would personally recommend having a look at the Hurricane Electric site, he.net. They are in the business of selling IPv6 transit. I don't work for them, by the way, but you know, they make their money selling transit to ISPs, so they want people to know about IPv6. They want all of you at home using IPv6 so that your ISPs are going to have to buy transit from them. So they have put online courses and statistics up, and there's an online certification system you can go through, and if you do, you'll get a lovely t-shirt. So it's quite a practical way of learning about IPv6. I would have liked to do sort of take you through a practical step-by-step, but you know, we'd need a sort of different sort of forum for that. And to get fully through that course, you need to set up an MX server that's got IPv6 support. You need to set up a domain with IPv6 glue. So if you started doing the certification thing with, for example, a .com from a registrar that didn't have full IPv6 support, you'd have to stop and start again with one that did. You very quickly learn what works and what doesn't. So start using it. If you're a developer, test your software. You really need to be getting that support in there as soon as you can. Because some of your customers, some of the people who are trying to use your gear are going to require that IPv6 support. Demand IPv6 from your ISP. Ask them annoying questions. Get them on the phone and say, you know, if you're thinking of setting up with a provider, you're thinking of getting hosting from an ISP, then ask them, do you have IPv6 support? Can I set up Quad A records on your DNS servers? And if they don't know what you're talking about, perhaps consider choosing somebody else. If you're getting virtual machines and this sort of thing, insist that they have IPv6 support. So, that's enough about me. What about you? How many people here have really heard nothing much about IPv6 before today? How many people have heard lots about IPv6 before today? Right, so those two numbers didn't match up, but there's a lot of shy people in the room here. So, how many people are running networks at the moment? Right, and do you have IPv6 on your network? Yes. How many people look after firewalls? That sort of thing. Many of the same hands, obviously. I should hope so. And do you actively control IPv6 on there? No. So what's your policy? Do you block it or do you filter it? Okay. I mean, if you have a firewall at the moment that's only supporting IPv4, have a look at the software you're running. Do that soon. See whether you are controlling IPv6 or not. You may find that you've got a gaping hole in your network that anyone can just walk through. You may find you've got devices on your network running IPv6. It's quite hard to stop things from running IPv6, to be quite frank. You have to go to some deliberate effort. So if you should really be checking that. And as a quick fix, you can just get IP6 tables in there on your router or whatever you're using and just block it as a start. But obviously that's not the long-term answer. You really need to be applying the same filtering rules that you apply on your IPv4. And that might take some work. That might mean changing what software you're using. If you're using your own IP table scripts, then it's very easy to put in. The commands look almost exactly the same. So, are there any questions?
Yes, I would know if IPv6 will make people to be more to have more privacy. I mean, if it is impossible to generate all addresses, maybe there is more difficulty in a lot of more difficult to spy on them. I mean,
Well, the answer to that, I would say, is both yes and no. In some cases, just the sheer size of IPv6 works on your side in the same way that you're standing in a much bigger crowd, you're less likely to be spotted. If you are running Nmap, for example, to do a discovery on a network, it takes a lot longer to do that on IPv6. Obviously, they're optimizing that all the time and so on. And until fairly recently, because of the lack of deployment of IPv6, there were a lot less attacks. But I wouldn't say that's any longer the case, because there are Teredo tunnels automatically turned on, because a lot of administrators aren't aware of IPv6 and haven't done anything about it. A lot of attacks are now starting to be targeted specifically at IPv6. It's a big space to scan, but as most people use the addresses 1 and 2 for tunnel endpoints, you can kind of skip all those zeros in the middle. If you want to have a bit of security by obscurity, use a bit of anonymity, then you can pick a different number in there. It means a lot more typing, so most people don't. They like to use that double colon as much as possible to get as many zeros into the address as possible. But really, you shouldn't be relying on the size of the IP space for your security. You should be doing proper filtering. Does that answer the question? Okay.
I think we still have like 6 minutes for questions. So.
Uh-oh.
Well, I have more a comment than a question. I'm running IPv6 at home, and for a few months already, my experience is good so far. But how to say? Like, the most common problem as an IPv6 user is not that the network is not running, but they are application developers. Especially, I have found many websites that they are still checking a session, not only the cookies, but also the client IP address. For example, Ubuntu enables by default the IPv6 privacy extension, so your IPv6 address is changing all the time. This, or the result of this is that every few minutes, some session on some old websites or poorly designed websites, they are timing out. So it's a bit annoying. And I think network administrators, they are starting to be aware of IPv6, but developers, they are not. And I think it's going to be the next focus on IPv6 deployment.
Absolutely, I think you're quite right. Mostly things like the network stack and so on, and Linux and Windows and Apple and so on have all been updated. A lot of things are capable of running IPv6, but various bits of software haven't caught up. So as I say, web interfaces from hosting providers and this sort of thing, the underlying daemons might support it, but it doesn't. It's not always supported in the web interface. You'll often find that it hasn't had as much testing either. There might be IPv6 support there, but you might be maybe not the first person using it, but one of the first using it. And even though your hosting provider might give you IPv6 to play with, we were certainly with our upstream providers one of the very first using IPv6. And so we would be reporting outages to them. And they say, oh, we had an outage 4 hours ago, but we fixed it. And so, well, yes, you fixed it for IPv4, but you're still down for IPv6. Nagios is screaming at us. So, yeah, you find yourself on the bleeding edge because you're adopting it early. A lot of the early teething problems are gone. There's much better support in software now. As I say, Quagga before didn't have... it had problems with BGP support when we were trying to advertise routes to our upstream providers, and that was fixed. We were able to backport a fix from a newer version. Exim still had some problems last I was looking, but again, it's open source. It will get fixed, and if it doesn't, you can fix it and give them a patch. So test it, get involved, and so on. Any other questions?
No questions?
Okay, well, I have a final question for you then. Who here is going to go and learn more about IPv6 and make sure it runs on their systems? Either you're doing it already or you're going to. And who can't be bothered? Who's going to wait until it comes to them? Okay, nobody's admitting to that, but again, the numbers don't match up. So I leave you with that thought. It's coming, be ready for it.
Thank you.
Thanks.